Hello friends, now we start first lesson similarity in Maths 2 and next topic is basic proportionality theorem. In last topic we studied the property of ratio of areas of two triangles. Now using this property we prove first theorem, basic proportionality theorem. In short we also say it is BPT. Okay. Now statement of this theorem is if a line parallel to a side of a triangle intersect the remaining sides in two distinct points, then the line divides the sides in the same proportion. Means this theorem says if if a line is parallel to a side of a triangle, then it divides the remaining two sides in the same ratio or in the same proportion. To prove any theorem, first step is we have to draw figure, because figure is very important in theorem. Using that figure we prove the given theorem. So first we draw triangle ABC, then we draw parallel line L to this side BC. This line L intersect this AB at point P and AC at point Q. Using this figure we write second step given. We write in triangle ABC, line L is parallel to side BC and this line L intersects side AB and AC in point P and Q respectively. Now we have to show that this line L divides these two sides in the same proportion, means we have to show that AP upon PB equals to AQ upon QC. Okay, so we write in to prove AP upon PB is equals to AQ upon QC. Now to prove this property we have to use property of ratios of areas of two triangles. So we have to make one construction. So what we do? We join these 2 points CP and BQ. So we write draw segment PC and draw segment BQ. Now next step is we have to prove this theorem. So we start proof. So first we take two triangles. Which two triangles? We take triangle APB and triangle BPQ. If we consider these two triangles, then we find that this P and Q are the common vertices. So in this two triangle APQ and PQB, heights are equal. So it depends on its corresponding bases. So we write area of triangle APQ upon area of triangle PQB is equals to AP upon PB. Give reason as triangles having equal heights. We call this is equation number 1. Similarly, we take another two triangle APQ and triangle CPQ. In this two triangle also PQ, these two vertices are common, so heights are equal. So it depends on its corresponding basis. So we write area of triangle APQ upon area of triangle PQC is equals to AQ upon QC. Okay, we call it is equation number 2, triangles having equal heights. Then we have to show that AP upon PB and AQ upon QC, these two sides are equal, these two ratios are equal. To show these two right sides are equal, we have to show these two left sides are equal. And if we consider these two left sides, then we find that this area of triangle APQ, area of triangle APQ means numerator is same. Now we have to check whether this denominator is same or not. So in this case, area of triangle PQB and area of triangle PQC. So these two are different. म्हणून आपल्याला काय करावं लागेल की आपल्याला पाहावं लागेल की हे दोघं इक्वल आहेत का या दोघांचे एरिया. So we consider these two triangle PQB and triangle PQC. Now these two triangle BPQ and this CPQ, these two triangle lies between these two parallel lines. And we know that if two triangles lies between two parallel lines, then heights are equal. Okay. And these two triangles have common base, this PQ. So we say area of this triangle PQB and area of triangle PQC, these two areas are equal because triangles having equal base and height. Now these two areas are equal, so numerator equal to hai, denominator also we show it is equal. So from 1, 2, 3 we say these two ratios are equal. Now if these two ratios are equal, means left sides are equal, therefore we say these right sides are also equal. So AP upon PB is equals to AQ upon QC. Means we prove this BPT, basic proportionality theorem, using properties of ratios of areas of two triangles. Okay. Then we have to take converse of BPT. Now in converse of BPT, basic proportionality theorem, what is converse? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now what is this theorem says? In theorem we say if line is parallel, then it divides the remaining two sides in the same ratio. Now converse of this theorem says if a line divides any two sides in the same ratio, then the line must be parallel to the third side. So we draw this figure, triangle DEF. This is line L. Now what is given? If DP upon PE is equals to DQ upon QF, then we say this line L is parallel to the side EF. Okay, this is converse. Means in theorem we say if a line is parallel, then it divides the remaining two sides in the same ratio. And in converse we say if a line divides the two sides in the same ratio, then it is parallel to the third side. So this is BPT, basic proportionality theorem, and converse of BPT.